Let's move to the next topic, that is the graphic representation of data. First comes the histogram. Histogram is simply a graph showing the frequency in the tabular form. Let's say in the previous case, we have for less than 3% we have 0 frequency. For 3 to 5% we have 1 frequency. For 5 to 7% we have 0 frequency. For 7 to 9% we have 2 observations. For 9 to 11% we have again 2 observations. So this is my histogram. So on x-axis I am having intervals, while on the y-axis I am having frequency. A frequency polygon is like we are joining the midpoints of the intervals with each other. So when I will join the midpoint of the interval 1 with this, next with this, and next comes out to be this. So this line is representing my frequency polygon. Cumulative frequency distribution is when I am taking cumulative frequencies. So if I represent the above table, I will get it like for 3 to 5% I have 1 observation. For 5 to 7% I have 0 observations, but the previous is cumulative, so I will here represent as 1. For 7 to 9% I have 2 observations, so now the total number of observations come out to be 3. For 9 to 11% my total observations come out to be 5. So this is the cumulative frequency distribution. Guys, again, this is not a very much important topic from the testability perspective. So please don't spend much time on this topic. Let's come to the measures of center tendency. So first, the center tendency is finding the central point of my observations. So these include mean, median, and mode. So mean is arithmetic mean is a simple average of all the observations. Like in our previous example, the sum of all the observation is 7 plus 8 is 15, 15 plus 9 is 24, 24 plus 3 is 27, 27 plus 10 is 37%, divided by number of observations, that is 5. So it turns out to be 7.4%. So my 7.4% represents the middle point of all these observations. So when I am finding the mean of the population, that is known as population mean, and it is represented by mu. And when I am finding the mean of sample, then I would say it sample mean, and it is represented by x bar. The formula is the same, while n is the number of observations in population. While in this case, n is the number of observations in sample I have taken from the population. So next comes the second topic, that is median. So to find the median, first I will arrange my data, that is the previous observations what we are taking, in, let's say, ascending or descending order. So I am arranging them in ascending order, then this 3% will come in front. Now since there are how many observations? 5, 1, 2, 3, 4, 5. So I will find the midway of the observations, that is 3. Now here 2 observations are lying on the left and 2 observations are lying on the right. So the simple formula is number of observations, that is 5, plus 1 divided by 2. So it turns out to be third position will act as my median. Now in case if I have another observation, let's say it was 13%. Now I am considering 6 observations. So now how I will find it? As in this case, on my third and my fourth position, there are 2 observations on both sides. I will simply take the mean of both. So it will come out to be 8% plus 9% divided by 2. So 9 plus 8 is 17. 17 divided by 2 is 8.5%. So 8.5% will act as a median. Now in a general form, it can be represented for even number of observations. Median is mean of the n by 2 observations, that is 6 by 2 third position, and n plus 2 by 2 observations, that is 6 plus 2 by 2 or fourth position. So that is the mean of the third and the fourth position. That is what we have done here. Please don't forget that the observations has to be arranged in ascending or descending order. That is a prior requirement to find the median. And let's come to the next topic, that is mode. So mode is simply defined as the most frequently occurring value in any distribution. So let's say I have the stocks returns as these 6 numbers. So here 3 is occurring 2 times, 4 is occurring 1 time, but 5% is occurring 3 times. So it is the highest occurring value in any distribution. So it turns out to be 5%. So that represents my mode. So let's say if I have another observation of 3%. So now 5% is repeating 3 times and 3% is also repeating 3 times. In this case, we have 2 modes. So it is known as bimodal. While in previous case, we were having only 1 mode, so that is known as unimodal. Similarly, if we have 3 modes, then it is known as trimodal. Now when all the numbers here are equal, then we have no mode. So we have no mode when all the observations are same. So all the observations are same. Let's come to the next topic, that is the weighted mean. Weighted mean is simply finding the mean according to proportions. Let's say I have 3 stocks ABC and I have invested the amount as 40 in stock A, 60 in stock B and 100 in stock C. Now let's say the return generated from these stocks are 5%, 7% and 9% respectively. Now the one case to find the mean is I simply find the average of these 3 returns. But in this case, since the amount invested is different, so we will take the returns according to the proportion of the amount invested. So the weight assigned to the stock A would be the amount invested divided by the total amount, that is 200. So the weight turns out to be 40 upon 200, that is 1 by 5, or it is 20%. In this case, we are having a weight of 60 upon 200. It turns out to be 3 upon 10, so it will become 30%. While in last case, I have 1 by 2 or 50%. So I will take the mean according to the proportions of the amount invested. So the weighted mean, which turns out to be 20% or 1 by 5 of 5%, that is 1%. For the stock B, the proportion is 3 by 10 of 7%, that is 21% upon 10, or it will become 2.1%. In the last case, it is 1 by 2 of 9%. It turns out to be 4.1%. So now my net return is 7.6%. Now when we were doing initially, what we were doing is we were taking the equal weights with a weight of 1 by 3. But that is not true because we have different kinds of amount invested. In case if we have equal investment in all the stocks, then we have taken the equal weights. So it turns out to be 1 by n. That would be the rate assigned to the each stock. So in general, it will turns out to be the simple mean, that is summation of observations divided by number of observations. So next comes out to be the geometric mean. So geometric mean is a little different from arithmetic mean because now it considers the effect of compounding. So if you remember, if we have to find geometric mean of two numbers, that is geometric mean square x1 into x2. This is something what we have done in our earlier classes in primary education. So if I have to find geometric mean of three numbers, it would become geometric mean q equal to x1 into x2 into x3. So similarly, if I have to find geometric mean of n numbers, so it would be geometric mean raised to the power n equal to x1 into x2 into x3 continued to xn. So this is the geometric mean in case of numbers. But when we have to find the returns, so we will find it 1 plus Rg, that is a geometric mean, raised to the power n is equal to 1 plus R1 into 1 plus R2 into so on to 1 plus Rn. Now here n is in power, so on the other side it will turn out to be under root. So it will become under root n of 1 plus R1 into 1 plus R2 so on to 1 plus Rn. Now to find the geometric return, so here 1 I will take it to the right hand side, so it will turn out to be minus 1. So this is a simple formula for finding the geometric mean. The geometric mean is similar to if somebody has read about CAGR, that is compounded annual growth rate. So geometric mean is none other than a compounded annual growth rate, that is final price upon initial price raised to the power 1 by n number of years minus 1. So let's find the geometric mean of bonds of this stock or in 5 years. So the geometric mean would be 1 plus 7% will become 1.07 into 1.02 into, since it would be 1 minus 1%, that is 0.01 into 1.09 into 1.06 raised to the power 1 by 5 minus 1. So this 1 minus 0.01 will become 1.07 into 1.02 into 0.99 into 1.09 into 1.06 raised to the power 1 by 5 minus 1. This is the geometric mean of the bonds in last 5 years. Let's come up to the next topic, that is harmonic mean. Harmonic mean is simply the reciprocal of the arithmetic mean of the reciprocals of the numbers. Let's say there are two observations, x1 and x2. Now I want to find the harmonic mean of these numbers. So first I said I will take a reciprocal of these numbers. So it will become 1 by x1, 1 by x2. Next I will take the average of these two numbers, that is 1 upon x1 plus 1 upon x2 upon 2. Next step is I will reciprocate this, that will become 2 upon 1 plus x1 plus 1 upon x2. This is a simply harmonic mean. So this is the way you find the harmonic mean. The harmonic mean is used in the case of SIPs. Let's say I am investing in SIPs, or let's say I bought a stock A. I invested 1000 rupees in stock A and the per unit price of stock A was 100. In stock B also I have invested 1000 rupees, but the stock price was 200. Now if I simply want to find what is the average price of both the stocks, like I have purchased A and B, so what is the average price? Most guys will do that will become 100 plus 200 divided by 2, it is 150. Guys, this is wrong. How? Let's take. I want to take the average price. It would be total price paid divided by total stocks. Now the total purchase price is 1000 plus 1000, that will become 2000. And how many stocks of A I have bought? That is 10 stocks. For B I have bought 5 stocks. So total it will become 10 plus 5. So it will become 2000 upon 15. It will become 400 upon 3 and it will turn out to be 133.33. So this is the average price. It is not 150. Since the amount invested is same and the share prices are different, because of that when we have to find the average cost, where we can find it simply using the harmonic mean. This is a major application of harmonic mean. Guys, this is important. It can be tested in the exam, and there are, I would say, there are less chances, but still it can be fine. So it can have us, we can see one or two questions on harmonic mean. Next comes with the measures of location. Location is simply if I want to find what is the location of the data. Let's say I want to find how many numbers are there, like what is the number below which I am having my 25% of the total data. So let's say I have a range of data. So what is the position of a number such that there are 25% of total observations lying below? So this is how we find the measures of location in the data. This is known as quartiles. This location is measured in quantiles. So major quantiles are quartiles, quintiles, deciles and percentiles. Quartile is on the basis of 4 quarters. Quintile is on the basis of 5 quintiles. That is, it is divided into 5 parts. Next, in decile, we divide the distribution into 10 parts. So here we will have the breakage as after 10%. So if I say below this point there are 10% observations are lying. Below this point 20% population are lying. Below this point 30% of my observations are lying. Next comes with the percentile. Percentile means per cent. Per cent means per 100. So now I divide my observations into 100 quintiles, 100 parts. So now when I say below first point 1% of my total observations are lying, below second point 2% of total observations are lying. So in this manner I can find how many observations are lying below any specific point.